Okay, let's just look at the example 2. Okay, so the first part in this question is actually asks you to rewrite it into the form of P over Q. So let's copy this function. Okay, so if you want to group it into P over Q, only one fraction without this plus 3 is actually try to make sure that they have the same denominators. Okay, this is actually over 1. So in order to have to group it together, means that you have to multiply top and bottom with x minus 2, x minus 2. So when you have x minus 2 multiplied with here, we have the same denominator. When you have the same denominator, basically you can write one time on that. Okay, so we just can write one time on x minus 2 because you multiply, you have the same denominator. On the top, you have x plus 2 plus 3 multiply with the x minus 2. Alright? Okay, we just group the denominator. Okay, once you have grouped the denominator, the next thing that you have to do is you try to expand it. Okay, try to expand this. Okay, so we have x plus 2 plus 3x minus 6. So ends up we will have 4x minus 4, x minus 2. So that is your function f. Okay, so they ask you to rewrite it in terms of p over q. Yes, this is the form of px over qx. Okay, once you have done that, okay, the next thing we have to do is to find the x-intercept, y-intercept. Okay, so okay, let's just go for the part B. This is the part A. Okay, so the part B, they ask you to find the x-intercept, y-intercept. Okay, so for the x-intercept, that is common for every single question. You have to let y equal to 0. Okay, what is your y? Your y is this. Okay, so you let this one equal to 0. Okay, so 0 equal to 4x minus 4. This is x minus 2. Okay, solve it. We will have x is actually equal to 1. Okay, then we have the next. Okay, we're going to find for the y-intercept. So for y-intercept, that is the term you let the x equal to 0 and you substitute in here. So you have your y equal to f0, that is 4, 0 minus 4 over 0 minus 2. So ends up you have y equal to minus 2. Okay, now for the part B. So go for the part C. You need to find vertical asymptote and horizontal asymptote. Okay, so let's just look at the C. Okay, vertical asymptote. It says that you need to let your qx equal to 0. Okay, just refer back to your paper. Refer back to your paper. That is the flowchart that is here. Let your qx equal to 0 to get your x. So this is qx. Okay, so let qx equal to 0. This is your qx, that is x minus 2. So equal to 0, you have x equal to 2. And we are interested to know the horizontal asymptote. Okay, asymptote. So, okay, again, let's just go back to the flowchart. Flowchart say what? Okay, let the rational function, okay, let y equal to the rational function and put a limit in front of it. Okay, so you have y and you have a limit, and the axis approaches to plus minus infinity, and you have 4x p over q, right? Okay, so you have 4x over 4, 4x minus 4 over x minus 2. Okay, it's this one. Okay, so again, okay, try to apply the knowledge that we have here in limits. So you will have y equals to, okay, so in order to solve it, so you have to divide by the highest power that you see in here. So that is x, so you have x over x divided by x over x, 2 over x. Okay, so simplify it, you will have y equals to the limit infinity. Okay, this is actually cancel. You have 4 And 4 over x divided, okay, cancel, you have 1, you have 2 over x, okay, so substitute the infinity into here, you have 0, you have 0, so you have 4 over 1, so basically 4 over 1 is 4. So that is our vertical asymptote. Okay, so done for the part C, we go for the part D. Okay, so for the part D, they interested to know interval where the function is increasing or decreasing. Okay, so back to the flowchart one more time. Interval of increasing or decreasing. That is, you have this. Okay, so you have either this or this, but before you identify the part, you need to go to the basic. The basic is you have to find the f prime. You have to find the f prime and you check the critical point first. Okay, so go for the f prime. Okay, so let's just see our f first. So this is our f, right? Okay, so since you have fx equal to 4x minus 4 x minus 2, we don't use the question anymore. Okay, once you have obtained the p over q, the fractions in terms of p over q, we don't use this anymore, right? Okay, we just use this directly. So alright, okay. So again, we need to apply the equation rule. Okay, so you have u over v. So you have to let your u as this, v as this. Okay, so f prime, we're going to use the formula of v du minus u dv over v squared. Okay, our v, that is x minus 2, du is 4 minus u, the u is 4x minus 4, dv is 1. And we have the v squared, the v squared is x minus 2 squared. Okay, if we expand this, okay, we basically have 4x minus 8, and this is minus 4x plus 4, right? Okay, 4x and 4x, okay, you can minus, okay. So ends up we have f prime that is equal to minus 4 over x minus 2. Okay, so we just finished finding, we just finished on the f prime, so we have to identify whether it has the critical point or not. Okay, so in order to identify the critical point, it's same as usual. So you need to let your f prime equal to 0. What is your f prime? Your f prime is this one. This is your f prime, right? So let this one equal to 0. You will have 0 equals to minus 4 over x minus 2 squared. Okay, and again, this will give you a false statement. Okay, because it's impossible to have 0 equal to minus 4. Okay, if you have a false statement, okay, so it means what? It means that you are unable to get the critical point, so you have to use the x from vertical asymptote to view the table. Okay, so you are not in here, but you are in here. Okay, so we have no critical point. And then if you have no critical point, instead you need to use the vertical asymptote. Use x from vertical asymptote. Okay, vertical asymptote, that is x equal to 2. Just now the answer from the answer that is this one here. Okay, x equal to 2. Alright, okay, so we're going to use this x equal to 2 to build the table. Oh yeah. Okay, With the table, okay, so we have the interval table. Okay, so we're going to talk about the interval of increase. Okay, the table of interval of increase or decrease. So you will have an interval. So that interval you just have one number, that is 2. You put the 2 on the top, 2 on the top, okay. Put the x equal to 2 here. So in here, let 2 to negative infinity to 2, excluded the 2, so 2 to infinity. And you're going to put in your test value. So in here, I'm putting 0 and it's 3. And again, okay, we're talking about interval of increase or decrease. You're going to test on f prime, sign of f prime. Okay, so do the substitution. You will have negative and negative. But basically, both are negative, so you're only having interval of decrease. Interval of decrease, okay? So you have negative infinity until 2, union with 2 until infinity. We don't join them because 2 is excluded, right? Okay, so then for the interval of interval where the function is increase or decrease, we go for the concavity. So if we're talking about concavity, so same thing, you have two parts, okay? So either on this or this, okay? So means that you have to check on your inflection point, okay? Before you check inflection point, you have to find your f number prime, okay? If you observe that we actually don't do this because we do not have critical point, so we don't do this, okay? So we just directly go to here and here and either these two, okay? So go for f prime first. Okay, since you have this, okay, so we go for this is your f prime. So write it in a way that easy for you to differentiate. So you have -4 and x minus 2 power of minus 2. Okay, we don't use equation rule. Yes, you can use equation rule, but equation rule will give you a very lengthy calculation step. Okay, so we just use the chain rule. So this one is give you 8 and x minus 2 minus 3, and chain rule is 1 here. So we have actually 8 equal to x minus 2 power of 3. That is your f prime. Alright, okay, done with your f prime. So now we are going to check whether you have an inflection point or not, right? Okay, so find the inflection point. So let the f double prime equal to 0. So you let this one equal to 0, you have 0 or equals to 8 over x minus 2 power 3. And we will have a fourth statement also. So we have 0 equal to 8, that is fourth statement. So if you have a fourth statement, that is means that you have no inflection point. So if you have no inflection point, I say what? It says that you have no inflection point. Use x from vertical asymptote to form the table. So use vertical asymptote. Okay, what is our vertical asymptote here? That is x equal to 2. So x equal to 2. So from the interval table for the concavity, right? Concave up or down. So we have the interval. So my interval, that is you have 2 here, 2. So basically you have negative infinity until 2 to positive infinity. So test with the value. The test value, that is 0, and I'll put 3 here. And again, so you're going to check the sign, the sign of f double prime. So okay, after you have substitute the value into here. So we have here the sign is minus and the sign is a plus. So you have an interval of decrease that is negative infinity until 2, and we have interval of increase that is 2 to infinity. So now we're going to draw. Okay, we need to draw, so there are information that we need to have. Okay, so let me go back to the previous part and to get the information that require for sketching. Okay, so this is the information that all that we have just now. I already copied. Okay, so this is all the information that require for us to look at when we need to draw. Okay, so as you can see, that I already highlight. You have to focus on the x, the vertical asymptote and horizontal asymptote before anything else. Okay, so let's draw it first. Okay, okay. There's a plus sound. Okay, there's a minus sound. Okay, so in here, okay, so what we have here is okay, let's draw first. Okay, so you have your vertical asymptote that is cut at x equal to 2, so that is roughly here. So that is x equal to 2. X equal to 2. Okay, and we have y equal to 4. So y equal to 4 is let's say roughly here. Okay, we have y equal to 4. So just focus on the vertical and the horizontal asymptote first. Vertical asymptote, horizontal asymptote. Okay. So once you have drawn the vertical and horizontal asymptotes, we look at the x-intercept and y-intercept. For the x-intercept, okay, intercept at x equal to 1, and for the y-intercept is intercept at y equal to 2. So y equal to 2 is here. So it means that later you're going to cut these 2 points. Okay, let's look at the curve that we need to draw. Okay, we have to see this both. We have to check on this both table. So you look at this one. So it means actually you have a curve that is going down, right? That is decreasing. And you look at this one. This is actually a curve of concave down. So you join the function of both is basically over here. It couldn't be on the top because if you draw on the top, it will cut through. It will cross through the dotted line. That is not what you want. So you have to consider the down part, because down part, you have to be logical, because you have to draw the curve going down, and you have to concave down, and you have to cross these 2 points. So it means it should be here. Okay, so you are decreasing, and concave down. Okay, and the next is actually the same. We are having a decreasing. Here we have a decreasing function, and this is a concave up function. Decreasing and concave up. Okay, how does this mean that? Since that you have something set concave up, if concave up is something like that, it's impossible for you to draw here, but it's here. Alright, because you cannot cut this line, you also cannot cut this line. So if you draw that region, it should be somewhere here. Right? Okay? Gonna be down here. Okay. So it will be here. Okay, after we have drawn, okay, so let's just double check on what we did just now. Okay. So it says that you are having a function that is decreasing. The value of y is always reducing. Okay. So the value of y is always decreasing by you going down, right? Going down. Okay, it's decreasing. And for here, the same thing, you have a value of y that is always reducing or decreasing. So the value of y is always decreasing by you going on. It's decreasing. Okay. How about the concave up and down? For the concave up and down, so it's just to see that, okay, so you have a curve of up, and so you have a curve of down, so we have a down here. And you have a curve of up, that is here. So done. Okay, so that is the graph for this example. Okay, so